From Microbe TV, this is TWiP, This Week in Parasitism, episode 137, recorded on August 11th, 2017. This episode of TWiP is brought to you by Blue Apron. Blue Apron is the #1 fresh ingredient and recipe delivery service in the country. See what's on the menu this week and get 3 meals free with your first purchase with free shipping by going to blueapron.com/TWiP. Hi, everybody. I'm Vincent Racaniello, and joining me today here in New York City is Dickson Despommier.
Hello, Vincent.
And from a remote location, Daniel Griffin.
Hello, everybody.
Hello, Daniel.
Wow, we are all together after like a month.
Yeah.
I went through a little bit of withdrawal. I missed you guys.
Hey, same.
Daniel, I went sailing and we didn't tip over.
That's a miracle.
And I went twice. And the last time, the winds were amazing. We cut through the water like butter.
Wow.
Oh, that sounds
Like
great.
Isn't it great? Isn't it great?
Yes.
And we were coming downwind. And my son said, boy, if we could just put up the spinnaker, then it would be really cool. We'd go even faster.
And did you?
Well, it wasn't on the boat.
Oh, I see.
We don't always carry it
That's
with
a
us.
problem.
But you can only use it downwind. It's kind of a pain, right, Daniel?
Well, I have a little bit of a sailing story. I was going to tell you guys, but I said, hey, why don't I wait? Last night was big boat spinnaker racing.
Wow.
So we go out on the 35-foot racing boat, and we spent a little bit before the race warming up, popping the spinnaker up and down, we're all ready to go. And now we're in the start sequence, and there's about half a dozen of these 30, 40, 50-foot boats coming into the line. And we noticed that something's a little bit odd with our steering.
Oh, no.
And so we come in, it's a little odd, and we do the start. And all of a sudden, the boat just starts bearing off. I'm like, well, what's going on here? And we lost steerage. Something about the connection of the wheel.
Wow.
And, here we are in the mix with all these boats. We're about to pop spinnakers. And so we had to pull off the plate. We had to pull out the emergency tiller. And now we're trying to somehow limp out of this situation. And, we think, okay, all the boats are gone. This is great. But now we realize here come 2 of these 40-footers with their spinnakers up. And I'm not sure we're going to make it across in time. So it got a little exciting.
Wow. Yeah,
And what happened?
And I was thinking, I better call Dickson and Vincent to let them know I may not be there for TWiP.
I'm glad you made it.
You almost got keel hauled.
These are the good days of sailing right now.
Good days.
Nice weather.
Oh, beautiful weather.
Blue skies. Yeah, I'm hoping to get a few days in this weekend. We'll see.
Wow.
Dixon, you want to go sailing, Dickson?
Sure.
I need some extra weight.
That was a cryptic backhanded.
Daniel, I went fishing with Dickson in Montana. We were out there for a couple of days together.
Oh, I heard it. I heard you were headed. So how was the trip?
Well, I went floating with Dickson for one day, and it was just stupendous. He's such a good fisherman. Now, all these years we've been talking about, now I have actually seen it.
Uh-huh.
He's really
it is.
amazing.
It is true. He is an accomplished, I would say, expert fly fisherman.
Yeah, he's an angler.
Yes.
Angler.
Would you say you're an amazing angler?
No, I wouldn't use the word amazing.
Actually, that'll be the title of this show, The Amazing
No,
Angler.
please don't do that.
No, Dickson is very
the nearly
modest.
complete angler.
Daniel, do you ever fly fish?
Not only do I fly fish, but I grew up fly fishing, and I've been fly fishing with Dickson. I started when I was a kid, and fly fished a lot. I used to love opening day up in Idaho. I used to try to make it up to Henry's Fork whenever I could.
That's a very difficult river to fish.
Yeah, it is. I'll say that. And my kids all started fly fishing when they were like 2-3 years old. We would go out in the evenings. Where I lived in Colorado, you could walk out the back door and fly fish.
Yeah, we passed some places like that, right? There's a house on the Bitterroot for sale for $3 million, which is right on the river. You can Daniel, if you could buy that, Dickson and I will visit you.
We'll take very good care of it for you when you're not there.
Okay.
Right on the river. Beautiful house. Right?
Yeah, it's gorgeous.
Yeah.
Gorgeous.
And I guess in the medical world, I've been seeing a lot of interesting cases to
great.
move away from parasites to virology. I saw a woman back from a cruise in the Caribbean, and her blood is now having neutralizing antibodies for Zika tested for confirmation. So
wow,
Really?
Look at that.
We just talked about that today on TWiP.
Well, you'll have to come to TWiP sometime and do a
crossover show.
Do a crossover.
yeah.
I want to tell you about this year's ASM Hot Topics in Microbiology Education online course. It'll help you measure whether your students are truly learning in your classroom or laboratory or not. Design a research project and learn how to gather and evaluate data to discover if your methods improve student learning. Join an online community of supportive faculty, mentors, and facilitators who will work with you through productive, interactive assignments. It's online and it's affordable. These are webinars that are taking place from August through December 2017. The registration deadline is August 28th. You can learn more at asm.org/courses. We'll have a link to the specific program in the show notes. Well, over a month ago, Daniel, you delivered a case, and I don't know if you remember it, but why don't you refresh us about it?
Oh, I see it. I see it written here in our show notes. This was a young. I guess I shouldn't say young. This was an 18-year-old, because young is what, judgmental, decisional. This was an 18-year-old Islamic college student that I saw when I was down in southern India. He had come from his home and was living in the dorms here in southern India. He was living in a dorm where there was a Hindu couple who were preparing all the meals, basically these dorm parents. And it was a large group of Muslim students, and this gentleman was an observant Muslim. And the reason he had initially sought medical attention was that he had developed a lump in the left side of his neck. Now, it was a 1 to 2 centimeter mass. He reports that previously he was completely healthy, no medical, surgical problems, no allergies. He prays, traditional multiple times per day, observes dietary restrictions, no pork, any meat would have to be halal. When I see him, he's afebrile, pretty much normal exam, except, as I mentioned last time, when I palpate his left sternocleidomastoid muscle, there's a 2 centimeter firm lump, and it's really in the muscle. It's not outside the muscle. It's not mobile. It really feels like it's in the muscle itself. It's not tender. When I'm seeing him, it's the end of November. It is the rainy season, but as mentioned, this has been going on for a little while. There was some questions about insect exposure, screens on the dorm windows, and no screens. There wasn't any animal contact specifically, but to give it context, right? We're in Vellore, southern India. There's dogs, there's cows, there's goats. I mean, there's your basic normal India animal exposure. An ultrasound was done of this lesion in the neck, and I intimated, I suggested, I hinted that ultrasound was helpful in us getting a sense of what this might be. And I don't think I mentioned much else other than just to sort of reiterate, this was a healthy guy, no weight loss, no night sweats. And I think then we left it up for some guesses.
We did.
All right, we do have some guesses. First one's from David. Dear hosts, I believe the young Muslim in India has contracted a rarely reported case of isolated cysticercosis from the pork tapeworm Teniasolium of the sternocleidomastoid muscle. This condition has been published in scientific journals a few times and was the first result to pop up on Googling sternocleidomastoid muscle parasite. The 1 to 2 centimeter mass fits the approximate size that the calcified cysticercus would create. Cysticercus.
Am I okay with that, Dickson?
Perfect.
Would create upon lodging into the muscle.
A bunch of nuns who go to the Burnham and Bailey Circus. Sister Circus. That's the way to remember it.
The fact that this lump represents no other symptoms shows this could be an isolated incident rather than a systemic infection. A brief summary on cysticercosis versus teniasis, right?
Yep.
When a human host consumes uncooked meat infected with the pork tapeworm cysticerci, the worm will mature in the small intestine as a full-fledged adult. However, when the eggs of the tapeworm are ingested, they will develop into larvae that can migrate out of the intestine, enter the blood, and circulate into musculature. Mm-hmm. There, the larvae will form cysts in about 2 months, and these may not present clinical symptoms for years. This can be dangerous if cysts develop in the brain, leading to neurosis. So, how did an Islamic student who does not eat pork, as it is forbidden under the rules of halal, come to be infected with pork tapeworm eggs? I suspect that the student either came into contact with eggs somewhere on campus, highly unlikely, as there would probably be no need for pigs to be anywhere near an Islamic school, or the most likely case is the Hindu dorm parents accidentally contaminated the food they were preparing for the patient. Pork is not explicitly forbidden in the Hindu religion, and it is possible that the cooks came in contact with pork tapeworm eggs at home or another local environment contaminated with pig feces. Mm-hmm. Cysts located in the muscle, particularly those that are asymptomatic, may be removed surgically or left alone to calcify and involute. However, antihelminthics such as albendazole or praziquantel may be used to treat the cyst along with corticosteroids to mitigate potential inflammation. Thank you once again for the informative and entertaining podcast. David is a student, PhD student at Tufts University. Dickson.
Right.
So actually, Dickson, before we go on to the next, there was a little bit that I thought as we go, maybe we should hit on. Sure. He mentioned here this idea that the Hindu dorm parents came into contact maybe with some egg. What do you think about that?
That's pretty rare, I would say. That's a stretch in terms of epidemiology. I think you'd need to have a person with an adult tapeworm somewhere in the picture in order for this to be transferred over to this individual, if that's what he actually has. That's my own opinion.
I think that's critical here is that, the problem is eating the eggs. Right. But, if you eat pork, which is what maybe we would assume here for the cooks, maybe the cooks ate the undercooked pork.
Maybe.
And then, that would be sort of a way of putting this together here.
That would be.
Okay.
But it's rare to see pork tapeworm in India, no matter what.
Mm-hmm.
That's what I think. I don't know that as an endemic center, whereas Africa and Central and South America, it's all over the place. Okay, so you want me to read the next one? Mm-hmm. Shane writes, Dear TWiP Trio, I am a longtime listener of the show, and in fact, I have been listening since the beginning of TWiP and listened to most of Vincent's podcasts. I used to write infrequently, but I don't have a lot of time anymore since you guys inspired me to go back to school at 40 years of age to study a Bachelor of Science majoring in microbiology at the University of Queensland. I plan on completing a PhD eventually and doing research in cancer immunotherapy, but at the moment, I'm plodding along slowly part-time as I still work full-time and run a gym. Now, on the case, I believe the gentleman from India is suffering from cysticercus, as caused by the parasitic cestode Taenia solium, although Daniel went to great lengths to stress that this man held to his religious beliefs and customs, implying he did not eat pork. His housemates, who were responsible for preparing the food, were not Muslim, and most likely consumed pork, and were infected with the adult form of the tapeworm, and most likely did not maintain proper hand hygiene and contaminated the food. I hope my guess is correct, and that I'm in the running for the book. Kind regards, Sean.
I don't think there is a book this time.
No, that's too bad.
Sorry.
That's right, but nice try.
In fact, I don't have a book yet from last time, which somehow I have to get.
No, I'll give you a book.
You're going to get it, and you both have to sign it and so forth. Dan,
yeah, actually, I have 10 more copies of the...
The new one came in?
So yeah, the new one. So we now have a Spanish hard copy version as opposed to we have a Spanish electronic version we've had up for a little while. And there's also a second printing of the English edition with a bunch of corrections, the addition of the parasitology superstars.
Nice. So, no, I'm anxious to get my share of those copies. Whenever they come.
All right. Dear TWiPtoids, my guess is that your Indian student with a mass in his left sternomastoid has cysticercosis, a pork tapeworm larva stuck in a dead-end host. Although this devout student strictly avoids eating pork, those who prepare his food do not. I suspect the parasite was acquired by fecal-oral transmission of eggs from a human carrier of Taenia solium. All the best, Dan.
It's Dan by Dan. Look at that.
How about that?
Alan writes, Aloha, esteemed TWiP pundits. Without a scan...
Pandits. We're
Pandits.
What is a pandit?
I have no idea.
Without a scan, the DD would be tough for this case. In India, I used to see TB scrofula in young and old, but not typically in adults. Neck lumps can also be caused by histoplasmosis, coccidiomycosis, and other fungal diseases, toxoplasmosis, and of course, onchocercosis, but not in India.
Right.
But the fact that it is very likely a parasite and that upon getting a scan you saw something interesting, my guess is that your patient is suffering from cysticercosis cellulose or human cysticercosis, an infection by the larval stage of the pork tapeworm Taenia solium. I will not comment on how a Muslim eating food prepared at a Hindu school might have acquired this infection. If the mass is a cysticercosis, it probably could be treated with albendazole 40 mg BID for a month or more. Keep up the great work. If I'm fortunate enough to be selected for the book, I already own Dickson's most excellent Parasites to Plowshares, but would sure love a hard copy of Parasitic Diseases 6th edition. Weather in Kona. About 27°C today, but I'm flying out this morning to Port Moresby and on to Wewak, PNG, where it'll be somewhat warmer.
Yes, somewhat, I'm sure.
Hope to still catch TWiP there if I can get to a Wi-Fi somewhere. Best regards, Alan.
Wow.
So I was going to say two things. One, 400 milligrams. But I think that the TWiP pandit, right? I think he was comparing us to using the term pandit, the Hindu scholar learned in Sanskrit and Hindu. So,
wow.
So I think that was a very, sophisticated little
yes,
addressment.
Indeed.
So thank you. I'm flattered, Alan, if that's what you meant.
Yeah, we all are.
Dickson, you're
Gavin writes, Dear TWiP team, my case guest for TWiP 136 is intramuscular cysticercosis caused by Taenia solium, the pork tapeworm. If I am correct, this is another interesting case of immaculate conception by a kosher/halal person. I must admit that I had to Google if Hindus eat pork. Google says maybe. So the dorm parents contracted the tapeworm by eating undercooked pork and transmitted it to the student via eggs and feces. There have been many cases reported of isolated intramuscular cysticercosis. That would be an unlikely best-case scenario for our patient, but CNS and eye involvement should be ruled out. Treatment will depend on what tissues are involved, but will most likely involve steroids and albendazole. The dorm parents and other students will also require treatment. The differential diagnosis could include abscess, TB, and lipoma. Thanks again for the fantastic show. I went to the Monterey Bay Aquarium last weekend, and it made me think of your Blue Apron commercials. So a lot of interesting edible fish, did you?
Sustainable. They were
sustainable, too. I'm looking forward to this week in immunology. Cheers, Gavin.
Maggie writes, greetings, TWiP Titans. I do appreciate the creativeness here,
yeah,
so
exactly.
Thank you. My guess for this week's case study is cysticercosis. At first, when thinking of parasites that encysted muscle, I jumped to trichinella or a sarcocystis zoeticist, but neither fits this case well, since both have encysting stages that are much smaller than the 2-centimeter lesion reported in the young Indian man. The reason that I did not immediately associate cysticercosis with this case is that I mostly heard about cases of neurocysticercosis and therefore was not as familiar with the characteristics of a case with an intramuscular cyst. However, after some Googling and consultation with Parasitic Diseases 6th edition, I found that the characteristics fit well with this disease, with this diagnosis, i.e. approximately 2 centimeters, hard cyst, embedded in muscle, a few weeks of rapid growth. The young man would have gotten this infection by ingesting the egg stage of Taenia solium, the pork tapeworm, likely as a result of some unsanitary food preparation techniques. Since he only seems to have a single intramuscular cyst, would you be worried about and warn of the possibility of neurocysticercosis, or just think of this infection as a fluke? I think that was a pun there. I believe that treatment would be albendazole, possibly in combination with praziquantel, but would depend on if there is an additional diagnosis of neurocysticercosis and or adult tapeworms in the gut. What do you do for patients like this who are exposed but have no control over their own food preparation? Is there a suggestion to warn those who do prepare the food, or just treatment and hope the infection will not happen again?
All right, there's one more, Daniel.
Let's see here. Tara writes, Dear TWiPtoids. Thank you so much for your podcast. I have an absolute passion for parasites and look forward to listening to your cases, research, and friendly banter on a regular basis. I'm a first-year pediatric resident at Baylor in Houston and will actually get to spend a year abroad as part of my program in Africa, in which I selfishly hope to see many of the wonderful creatures featured on your show.
Nice.
Based on the information you provided, I must make the assumption your patient does not eat pork, which rules out his having cysticercosis, tenuisolium, the pork tapeworm. For those who can't see, Dickson is nodding. He's bringing his head back and forth. The next parasite which comes to my mind, which forms cysts, is Echinococcus. My understanding is that Echinococcus granulosus more commonly forms in the liver and lungs. However, I did find that rarely in endemic areas, the hydatid cysts form in muscle tissue. They have a marvelous life cycle involving carnivores, such as dogs, and a sheep, goat, swine intermediate host. The diagnosis was sealed for me with a hint of ultrasound use, which is the go-to for low-cost diagnosis, though CT and MRI could also be used. Thank you for your delicious helping of parasitic knowledge this month. Parasite onwards. And I would love the chance for one of your books, Tara. Tara Ness, MD, MPH, pediatric resident, Baylor College of Medicine.
Of course, we should emphasize the fact that you can have the book instantly simply by downloading the PDF version right now from our website. So you got the book. What you want is a hardcover.
Yeah, they want to win it. People like winning stuff.
They do.
And I don't blame them. I would like to win $1 million so I could buy you a studio, Dickson.
No, you buy it for yourself.
Or a new fishing rod.
That would be good. I'd take it.
All right. So almost everyone had the same guess except Tara.
That's right.
So who's right? Dum dum. We could make this dramatic.
We could.
Who's right?
Perhaps we should ask for more evidence from the laboratory.
We should.
Yeah.
Who should we ask?
I think we should ask the doctor in charge.
Well, last time I intimated that an ultrasound was done. So let me actually, I sort of remember well when this case was sort of before me and thinking it through. So, here's this young 18-year-old boy. The first thing, which I hopefully gave in the history, was really what I felt was critical was the exam. And so when I feel this, down the sternocleidomastoid are a bunch of lymph nodes. So one of the first distinctions for me is, am I feeling an enlarged lymph node, which would be on the surface of the muscle?
Right.
Or am I actually feeling something inside the muscle? And it really was inside the muscle. It was really interesting. I spent a bunch of time. I have to admit, I asked the young man a few times, "Are you okay? I'm not hurting you," because I'm doing this very thorough exam. And so it's reasonably large, right? I mean, this is almost an inch, right? 2 centimeters in diameter. It's in the muscle, not extrinsic to it. And then I went back through the history a little more. Okay, so I've got some sort of what feels like a cyst or mass in the neck in this healthy 18-year-old. No weight loss, no fevers, no chills, no sweats at night, none of that kind of stuff. Because when you're in India, one of the first things you think about almost always is it TB, right? If you're in Africa, is it malaria or not? If you're in much of the world, is it TB or not? And the fact that he was so completely healthy made me think against tuberculosis. So now the ultrasound, and I think I made a note of what the ultrasound showed. So it confirmed that rather than being a mass, it was a cyst, and there was a central density extending out from one of the walls.
A bladder. Really, that's what they're called, bladder worms.
So what would be your take on this at this point, Dickson?
Yeah, well, I mean, it's not hydatid cyst. That's what I would say, because that is
true. Yeah.
Multiple inclusions inside of a larger cyst. So that's going to be out. And if you only saw one thing, it looked like like you took your finger and stuck it on a tennis ball and pushed it in. And then you can visualize your finger on the inside of the tennis ball. That's the way these things show up on X-ray or radiograms. And so that, for me, suggests that you're dealing with a single entity and that it's got its scolex invaginated. And what happens when you swallow these things is the scolex evaginates and then attaches to the wall of the small intestine and begins to grow. So they do call these objects bladder worms because they look like a little bladder, basically.
What's the stimulus for the evagination of the scolex?
I believe digestion through the stomach.
Interesting.
Yeah, being released from the tissue does it.
Yeah.
So my guess, I mean, if I had to guess it, of course, everybody gets a shot at guessing. I don't need a free book. Is that I would say this is an aberrant encounter with a single Taenia egg from an unknown source, which resulted in a sternocleidomastoid muscle cyst. That's what I
an
think.
Aberrant encounter.
An aberrant, sure. These are, it's going nowhere because it's in a human. That's not going to go on to be eaten by another human and then develop to an adult tapeworm. So it's a dead end, basically.
Now, if someone ate this young man's neck muscle,
right, they would develop an adult tapeworm.
Got it.
Yeah.
In their gut, their gut tract.
Yeah. So that was our impression at this point. So then we'll sort of put these out for our listeners to think about. So we felt like, okay, here's our story. Probably as some of our listeners, emailers intimated, potentially this young man was exposed through poor hand hygiene of the cooks. Possibly getting an egg into his food because they were infected with an adult tapeworm. Do we just say, okay, here we are, good to go, let's give this young man albendazole, or is there something else we do next?
Well, I think you have to do a survey for others.
Why would you do that, Dickson?
Well, because it's not unlikely that several or more eggs were swallowed at the same time, so that one of them is quite visible on palpation. But others may not be. That's
might be
correct.
Some in the brain.
Might want to do a CT scan.
Now, if you treat someone with one in the brain, is that bad? Is that what Daniel getting at here?
Not sure. But you have to be suffering from symptoms first in order to get treated for anything. So if it's silent and it's not doing anything, then you should probably wait. That's what I would do, at least.
Yeah. So this is, I think Dickson sort of hits this on, is that one of the concerns, we all learned for some reason, those of us who learn about parasites, we learn about Neurosis to Psychosis. I don't know, it's exciting and all the rest, but extra neural cysticercosis, like we're seeing in this young man, it's actually probably more common than we realized it.
Yeah, that's right.
And there was a point when people realized, hey, let's just do an X-ray survey of people who have neurocysticercosis, and you start seeing all these calcifications.
Exactly.
And you realize that, because right. I still remember being asked that question, like, what is it about? Is there a tropism for the brain? Why does it always go to the brain? And I think we now realize that it goes everywhere.
That's right.
It's not, it's not specially excited about going to the brain.
It could even go to heart muscle.
Yeah. It can go to heart muscle. It can go to skeletal muscle. It can go to brain. Really, they can be all over the place.
It's a crapshoot.
So when we see this lesion in the neck, we say, this could be in lots of other places. Now, where we care is if it is in the brain and we treat this person with albendazole, the subsequent inflammation that results from the death of the parasite can trigger seizures.
Correct.
So it's important for us to have a sense of the potential there. Now, I guess I'll say our separate topic of how do we treat neurocysticercosis. I remember I was down in Peru. I don't know if I ever told this story on TWiP before, but there were a couple of the world experts on neurocysticercosis. And they were talking about how several years back there had been a consensus meeting about how do you treat neurocysticercosis, and the idea that if there's one lesion in the brain versus multiple lesions in the brain. And one of the ideas was that if there's multiple lesions, you might treat with the idea of now you can sort of say, okay, sometime in the next 6 months is going to be my high risk for seizures, where if these have been acquired over time and are degenerating over time, they could be at risk for degeneration and seizures for some extended period of time. So there was at least this concept that you would, if they had multiple cysts, want to treat. If it had a single cyst, then it's less clear. Do you just sort of wait and whenever, or do you say, let's go ahead right now and treat so we sort of know when this seizure risk will develop? So in this case, we went ahead and did the CAT scan of the head with this question in mind of, what are we going to do? These findings may help us decide, should we treat? Or should we just let this thing in the neck undergo whatever its natural course is? Because it's a little uncomfortable. Maybe he's noticing this, but there's no life-threatening. There's no true illness going on here.
No, in fact, if it dies, it calcifies, right? So, and it will die eventually. About 10 years of life, that's all these things usually last for. And by the way, we should also mention that during its lifespan, it secretes anti-inflammatory substances. So there's no lesion around these things. It's absolutely silent in every possible way you can imagine, although antibodies are made against the secretions of the larvae inside.
Is it live?
Oh, yeah.
How do we know?
Because when you eat it, you get an adult worm.
Yeah, there's a couple. It's interesting, particularly in the brain. There's a whole progression. The same way I think when we discussed echinococcus, it going through various cystic echinococcus stages. So CE1 through 5. Right. There's actually an evolution in time to a final calcified form where it is dead. Yep. But until it becomes calcified, it's alive. It's still potentially infectious. So through imaging modalities, CAT scan is actually very good at picking up calcified ones. But sometimes in the brain, if you don't do an MRI, you'll miss multiple lesions. So you may think, oh, this is great, nothing going on in the brain. Well, nothing that has been going on long enough to become calcified. You do the MRI and suddenly, you see, I'm trying to think. It's like putting on special 3D glasses. Suddenly, things jump out that were not there before.
Sure, absolutely.
So that's been a big advance. The dual imaging modalities.
Daniel, since we're in the middle of baseball season, I can't help but think of the famous headline in the St. Louis Dispatch. I believe that was the name of the newspaper, when the pitcher for the St. Louis Cardinals, Dizzy Dean, got hit in the head with a baseball that he had just pitched. And they rushed him off to the hospital because he was knocked unconscious. And they performed an X-ray. And the headline of the paper the next day says, X-rays of Dizzy's head show nothing.
Yeah, show nothing. Wonderful.
So that was when you just said that you take an X-ray or a radiogram that doesn't involve MRI and you say the brain shows nothing. That's just
Was he a good pitcher?
He was a superb pitcher.
He played for Cleveland?
No, he was St. Louis, I think.
He had fastballs, right?
Yeah, the thing that ruined his career, I mean, this is totally on the side, but he got hit on the toe once by a baseball also that he had pitched. At very high speed, they come back at you almost faster than they go in. And it fractured his toe. But he didn't want to say anything about it because if you got removed from the lineup, you might not have found your way back into the lineup. Someone else could come along and take your place, right? So he kept pitching, but he couldn't pitch the way he used to because it altered his delivery. And he threw out his arm and his whole career was ruined at that point.
Wow.
Yeah. And he was quite a pitcher. I mean, he had a wonderful stylistic. He kicked his leg way up high before he.
Where is he now?
He's looking at daisies, basically. He's not alive.
So, Daniel, what did you do with this fella?
Yeah. I mean, wait a minute. Yeah. Did we confirm the diagnosis first?
No, but he's telling us what he's going to do now.
Okay.
Well, let me ask you there, Dickson. Do you feel confident at this point that you've got the diagnosis, or is there something more you would want to do?
I want to do one more thing, and that is I could do one of two things. One is that I could look for antibodies against Taenia solium, right? I could look for the antibodies against the antigens, and there are some tests that you can run for that. The other thing you could do is you could actually insert a needle into the lesion itself and withdraw fluid and obtain some antigen. And then using an antibody of known specificities, find out whether that's against Taenia solium or not. Those are the two things that I would suggest doing.
Mm-hmm. Yeah. So in this case, here we are in India, so not sort of resource
Understood
rich.
What you were going to say next.
But we did go ahead. We did get the brain imaging, which did not show any lesions, both modalities. So we're spending quite a bit of money.
Yeah.
But no, then he went ahead and he underwent a month of albendazole treatment.
Right.
And actually had improvement with the size of the lesion.
Well,
and when I left, he was actually in the midst of that, so I didn't get to see the full.
Sure. Now, if he was really concerned, if he was the patient that I would have been, without knowing what it was, and without a firm diagnosis, I mean, no pun intended here, I might want it surgically removed because it's in a good position. You could actually take it out by surgery, right? And then you could find out definitively what it was. So what if it turned out
the size, yeah.
Exactly. What if it turned out to be a lymph node, for instance, and you took it out and then all of a sudden that completely reorients your diagnosis, right? So you've got lots of issues to deal with, but thank goodness that the albendazole therapy worked.
But Daniel, when you left, it was not gone. Is this eventually going to clear entirely the mass? Gone to zero?
I will say not zero, but no, it should actually, it should calcify, it should get smaller.
Right.
But I would say on careful exam, you'll still feel, residual something there. And I think as Dickson points out, here in, there in India, this person ends up with inexpensive few dollars worth of albendazole for a month. Here in the U.S., it would be thousands of dollars, hospitalization, probably resection of this, just to be sure.
Yes.
Yeah. When you have resources, you use them.
You do. Well, you had imaging resources. It's interesting you didn't have the immunological diagnostic laboratory resources.
It's interesting, actually. Once you have an MRI or a CT, it's just electricity, right?
That's right.
So it's interesting. I mean, you pay the cost up front. Once you have it, you just keep running.
Sure. There's one other feature of this parasite that you might have been able to detect on MRI, assuming that you've got high-resolution MRI, and that is that the scolex of the adult Taenia solium, as opposed to the adult Taenia saginata, which is the beef tapeworm equivalent, the rostellum of this parasite has hooklets, and they can be seen, believe it or not, using a high-resolution MRI. So you could have actually made a definitive diagnosis on morphology if you had access to an instrument that would have given you that kind of resolution.
I guess the other thing I should also comment about, something that Dickson brought up, is that when you look at a big macroscopic, map of the entire world, where do you see Taenia solium? You get these sort of broad, sweeping things. But if you go to India, it's actually really like a patchwork quilt. Yeah. There are areas where there's really no cases, right? And then there's areas that are highly endemic. And you can sort of get a sense of the geography and who are in these areas, whether or not you're having pig consumption.
Right.
Yeah,
I'm Daniel. You've been to India, and I've been to India, and mostly for vacation, but also to give a couple of lectures. And some of the areas that we were in urban areas where there were, let's say, bridges over what you would think would at one time be a river, but it's not a river anymore. It's sort of like a slow, very highly polluted body of water. And there's garbage spread along both sides of that bank of that waterway. And we did see pigs, and we did see goats, and we did see cows foraging on the garbage that people were dumping along the side of that waterway. So it was very discouraging to see the lack of public health in some areas. And that's basically what this is a disease of. Because the way the pig acquires it is from human contamination, and that's how they get the cysticerci in their muscle tissue. And there's, you feel like doing something. What could you do? I mean, who do you complain to, or who you do you know what this is like over here? These people are subjected to these horrible living conditions. Why don't you do something? And you realize that the public health system in many areas is just overwhelmed with problems. And that's very discouraging to see. And that's part of the reason Vincent asked me once, why do you like to travel? What do you see in traveling? And you see things like this, and you can bring those lessons back, and you can use those as, these are the things not to let happen to you, basically. And you wish you could do more for those people.
But you can't.
That was my take. Well, you can. We're doing it right now.
So I was just going to say that. We are doing it, right?
We're doing it right now. And our intent is to get our publication out to as many people as we can.
So let me ask you, so Dickson, part of why I presented this particular case, why I like this case, is I remember there was the story of the Jewish families in, I say Western Long Island, other people say Brooklyn, where
or Long Ocean Parkway.
Yeah, where they had developed actually neurosis or psychosis. And so it was the very interesting, I thought, the good lesson on trying to get people to think like, okay, so here are people who do not eat pork getting cysticercosis. And how does that happen? So do you want to just for our listeners just go through the life cycle?
Yeah, absolutely. And by the way, the answer to that question is that they were contaminated. Their food source was contaminated by somebody who was harboring an adult tapeworm, and it turned out to be from northern Mexico. There are endemic centers for this throughout Central and South America and Mexico, and this particular community along Ocean Parkway, one of the families had this wonderful housekeeper. And they would marvel at her ability to maintain a clean house and to do the laundry and to cook the food and take care of the kids. And she was multitasking all kinds of different things and sort of was the hero of that family because she helped organize everything around it. So the neighbors started to ask, well, does she know anybody else from her community that could come and work for us? And in fact, that's what happened. About 7 or 8 of these women came from this one village in northern Mexico to work in disparate houses spread throughout the community of, in this case, they're Hasidic. No, they're not Hasidic Jews. I believe, I can't remember the sect, but they're very strict Jews along Ocean Parkway, mostly dealing with imports and exports of silk handkerchiefs and things of this sort. And in 7 different households, different age groups and both sexes, they came down with neurosis to psychosis. And the only connector was this original, let's call her a domestic technician for lack of a better descriptor as to what she actually did. And all of the people that she brought in, when they finally figured out what was going on, the CDC actually cracked the case. They did a stool examination and they found proglottids in the stool and eggs under her fingernails. And basically wherever they looked on her body, they found the eggs of Taenia solium. So they were quite astounded at the pervasiveness of how widely distributed the eggs get. And because I know this is a detail that maybe a lot of our listeners don't want to hear, but while you sleep at night, if you harbor an adult tapeworm, the proglottids break off and they are motile. They can travel throughout your gut tract without anybody's help. For instance, peristalsis is not necessary. They can actually crawl out of the large intestine through the anus while you sleep, and you'll find them in your bedclothes. Well, imagine someone who has an adult tapeworm and this happens, and they just, through, let's say, an automatic nervous reflex to an itch in the perianal region, they start scratching. You can imagine if there's a proglotid there, they can break it, release the eggs. They can contaminate their entire body this way by simply rubbing their mouth and their face. And,
sure.
And they don't acquire cysticercosis because their immune system prevents the larva that hatches from the egg from actually penetrating their muscle tissue. So they're protected, but everybody else is, of course, susceptible. So the life cycle is very simple. You ingest a piece of raw or undercooked pork that contains the cysticercus, the larval tapeworm, the juvenile as it's called. That then is digested away from the muscle tissue when you eat, and that stimulates the invaginated scolex to evaginate once it gets to the small intestine. The hooklets and the suckers allow it to grab a hold of the small intestinal tissue, and it just sets up home right there and then begins to grow and feed on your food that you digest. It also absorbs a portion of it. It takes about 3 months for this thing to grow up in your small intestine. It can reach lengths of 15 to 20 feet and with thousands of proglottids. Now, how does the pig catch it? And the answer there is that they're very unsanitary conditions in some places. Pig farms and people, pigs are peridomestic. They live inside houses sometimes. They live in the immediate environment. There's very poor sanitation in many areas throughout the Central and South America and certain parts of Africa as well. The eggs then are released from the proglottids from the human, and the human feces comes in contact with pigs. Pigs are indiscriminate. They'll eat that. And don't ask me because I'm not a pig, but obviously pigs don't seem to mind doing that. As they do it, of course, the eggs then hatch in their small intestine. The hexacant's larva penetrates through the tissue, gets into the bloodstream, and is carried to various parts of the body. And the next thing you know, the pig is now a focus of infection for the adult infection that follows by eating that pig raw or undercooked.
Dickson, way back on TWiP number 6.
Yeah, we've talked about this.
March 2010.
Yeah.
tapeworms, the long and short of it.
Yeah, that's
Vincent and Dick talk about the anatomy and life cycle of beef and pork tapeworms and why House was wrong about neurosis to sarcosis.
That's
Do you remember that?
I do remember.
What was he wrong about?
You're stretching me way back. I think he was wrong about it by saying how that was acquired. He actually didn't have the correct description of the life cycle.
Yeah.
Yeah, because I think he said that you caught the adult worm, you caught the larva by eating a proglottid. And that's obviously not how you do it.
So here is it was the pilot. And I have a description here. Let's see. Shortly after the start of class, kindergarten teacher falls to the floor, experiences seizures. Okay. And they eventually go through various stuff. And they decide that to treat her with steroids.
Well, that's part of it. That's not all of it. That's part of it.
So they go to the house. They find a package of non-kosher ham. House concludes that she suffers from cysticercosis due to eating undercooked pork. When the tapeworm inside of her reproduced, its larvae were absorbed into her bloodstream, infesting her brain. Remember? They had it all wrong.
They had their life cycle wrong. That's right. That's a good try, but they missed it.
Totally wrong.
Yeah, totally wrong.
Yeah. I mean, there is, I like House, so I'm gonna how could he be right? One of the things that we realized was, so we look for the culprit, like who infected these people, who gave them neurosis or sarcosis. Right. About 10% of people with neurosis or sarcosis, this was done, here in the U.S., about 10% of them actually have their own adult tapeworm.
Correct.
They may be auto-inoculating.
Wow.
They may have, so the person on House could have eaten that uncooked, unkosher, whatever, raw pork, gotten the adult tapeworm, then ingested.
Could have.
Somehow gotten some of their own feces contaminated with eggs, coming out. Ingested those and then gotten the neurosis or sarcosis.
You sound like an apologist for House in some way.
I'm just hoping they're going to bring it back.
He was so inappropriate. He was appropriate. No, I enjoyed his. Hugh Laurie was the guy who he's an English actor.
Yeah, he is,
and he has an English accent when you talk to him in real life. So to come up with this House persona. And he maintained that the whole time the series was on. I saw all the shows.
I like him. He's a good actor.
They were great. They were
Very
terrific.
good actor.
Absolutely terrific.
Not a good role model.
No, not at all.
For aspiring young physicians.
And you know where the series was shot?
No.
It was shot at the Princeton Health Center in New Jersey. Yeah. Yeah. I interviewed a potential medical student from Princeton. And I said, did you know that House is shot on your campus? He says, oh, we all know that. We go over and watch him film all the time. It was really quite interesting.
All right. Is that it? Are we done?
Well, yeah.
With that case, that is. We have other things to do.
I think we.
Anything else, Daniel?
I think that was well done.
This episode is brought to you by Blue Apron, the #1 fresh ingredient and recipe delivery service in the country. Blue Apron sets the highest quality standards for their community of over 150 local farms, fisheries, and ranchers throughout the U.S. And for less than $10 per person per meal, they will deliver seasonal recipes to your home along with pre-portioned ingredients. So in 40 minutes or less, you can make delicious home-cooked meals. They ship exactly what you need to make the recipe. They reduce food waste, and you can't overeat. You need a tablespoon of soy sauce. It comes in a little plastic container. It's beautiful. Their mission is to make you a great cook, make home cooking accessible to everyone. There is no weekly commitment. You can get food whenever you want it. You can get deliveries whenever you want it. And you can choose from recipes every week, or you can let them surprise you. Here's what's on the menu for August. I'm going to pick two here. Let's see. Miso butter salmon and lo mein noodles with cucumber and charm tomatoes. Basil pesto chicken with summer vegetable panzanella. Ooh, sounds good, right?
Sounds very good.
You can customize your recipes every week, depending on your preferences. Of course, if you don't eat meat, no problem. They have plenty of things to take care of you And they have a freshness guarantee that promises every ingredient in your delivery arrives ready to cook, or they'll make it right. Check out this week's menu. Get 3 meals free with your first purchase with free shipping by going to blueapron.com/TWiP. That's blueapron.com/TWiP. You'll love yes, sir.
What is Panzanella?
You don't know what Panzanella is?
I don't have a clue. It sounds like it's some kind of a pasta, but I don't think it is.
It is a Tuscan salad of bread and tomatoes.
Oh, my.
Chunks of soaked stale bread and tomatoes, sometimes onions and basil, dressed with olive oil and vinegar.
Oh, that sounds great.
Panzanella. Would you like one right now? I'll call Blue Apron. They'll get it here in an hour. Check out this week's menu. Get 3 meals free. Already said that.
You did.
You'll love how good it feels and tastes to create incredible home-cooked meals with Blue Apron. So don't wait. Blue Apron, a better way to cook. I'm always surprised that so many people like Blue Apron. They tell me, oh, I love your podcast and I love Blue Apron. Go for it. We have a paper that's kind of a crossover between TWiP and TWiM.
Aha.
It's been published in Cell Host Microbe, and it's called Cutaneous Leishmaniasis Induces a Transmissible Dysbiotic Skin Microbiota That Promotes Skin Inflammation. It's pretty interesting, Dickson. You'll see. Okay. It is from University of Pennsylvania, Funda Sao Oswaldo Cruz. Do you know that place in Brazil?
I've heard of it. I haven't been there, but I've
Universidad Federal de Bahia and the Instituto Nacional de Ciencias y Tecnologia Doenças Tropicais in Brazil. Oh, I just love pronouncing those names. Almost as much as pronouncing Blue Apron food.
Right.
First author, Ciara Gimblett, and the last author is Elizabeth Grice, or Grice, Grice.
And Philip Scott is on that paper, too, and I happen to know him.
Philip is there.
He is. He's second for the last.
And how do you know Philip?
From the American Society for Tropical Medicine.
So he's an old guy like you.
I wouldn't characterize him like that at all. He's a very bright investigator.
Old and bright are not mutually exclusive.
That's true. I would say
look at you.
He might be middle-aged.
We don't see age.
No, we don't.
We are blind to age.
We're mature.
What's the story here? We all know that we have a microbiome, every part of our body. In fact, there are no sterile fluids, Dickson.
None.
We used to say in the beginning, there are 7 sterile fluids.
That's right? What we were taught.
And now there aren't any sterile fluids
Correct.
anymore. We have a microbiome everywhere. Everyone's probably familiar with the gut microbiome.
I'm sure they are.
There's one on our skin, too.
Absolutely.
Which we acquire at birth. Depending on how you're delivered, you get a different microbiome.
That's
vaginal or C-section, different microbiome.
That's amazing.
So we now also know that bacteria can influence infections with viruses and bacteria and fungi. So in this paper, they say cutaneous leishmaniasis, is it do anything to the microbiome? Okay. And does that have anything to do with the disease as well? Is it a reasonable question, Dickson?
Absolutely.
Okay. So they actually, in this paper, look at both people and mice.
Of mice and men.
Mice and men. And that's cool because if you do just one, you're missing out.
This is true.
So they take 44 patients. First of all, Dickson.
Yes.
Cutaneous leishmaniasis. How would one get it? By a sandfly bite?
You would.
In what countries of the world would you get this?
Depends on, we have cutaneous leishmaniasis throughout Central, South, and Mexico, America and Mexico.
Would you get it in New Zealand?
No.
Australia?
No.
Zanzibar?
Yes.
It doesn't exist anymore.
That was a trick question. It's not fair. No, but you get it throughout Africa and the Middle East. That's another species, of course, and then throughout Central and South America.
These are all cutaneous, right?
Those are cutaneous leishmaniasis named after every country, basically, in South America. They're quite numerous.
So in this paper, which the authors are from Brazil, they would have it there, right?
Loads of it.
They got 44 patients who had Leishmania brasiliensis.
That's different.
Why is it different?
That's mucocutaneous.
Yeah, that's unfortunately one.
Is different.
But they say these patients had cutaneous lesions anyway.
Well, they all start out that way.
Yeah.
But they don't finish that way.
Yeah, 90% will stay cutaneous, but unfortunately about 10% can go on for a mucocutaneous manifestation if not treated.
Exactly.
So
the mice, though, were given Leishmania major.
Yeah.
Which is the Middle East form of cutaneous.
These patients had Brazilian.
That's right.
So they swabbed them at the lesion near the lesion
Yep.
and at the unaffected contralateral site. So, Dickson, if I have a lesion on my left thumb, what would be the contralateral site?
Oh, you're right thumb.
Oh, there you go. Well, you're smart because I had to look at the picture.
Oh, no, you went like this. You gave me a hint. You gave me thumbs up. How's that?
So then they can take these swabs. Do you know how they figure out bacterial diversity, Dickson?
You're going to have to tell me that one.
You don't know?
I don't
Think
know.
they're going to streak it out on a petri dish?
No, they're going to do a DNA analysis.
Yeah, they're going to sequence ribosomal RNA.
That's right. 16S.
Yes.
Yeah, very good. And that's how you can speciate.
That's how I told a urologist once that urine is not a sterile fluid.
And what did he say?
And he said, of course it is. And I said, no, it's not. And he said, yes, it is. You can't culture anything from it. And I said, you don't have to culture it to know that it's contaminated with bacteria. You just check for the 16S RNA. And he looked at me as though I was from outer space. That's okay.
How old was he?
No comment. I'm not giving out any more details on this one.
Probably not up with the literature, right?
And he was not that old, actually. He should have known better.
Did you then go see another doctor who was younger, wiser, and cured you?
You know, I did, and everything just worked out peachy keen.
And that other doctor recognized that urine is not sterile.
The other doctor was willing to concede that the condition might be caused by some microbe that's not culturable. Yes, that's correct. And treated in the proper way. Voila.
So what they found is that the diversity of the bacteria on the skin of these 44 people was lower on the lesion and compared to the adjacent skin and contralateral skin. So the lesion is decreasing bacterial diversity.
Wow.
What do you think of that?
Awesome.
And so you can look at all the different kinds of bacteria that are present, and when there's a leishmania lesion that goes down in diversity. And in fact, it increases in Staphylococcus and Streptococci.
So
that goes up compared to normal sites.
Understood. So these are weeping lesions.
Weeping, really?
Yeah, they're cratiform weeping lesions, or they're wet and moist.
Yeah.
But rarely, and I don't know if Daniel will agree with this or not, but I've never heard of any of them being microbially contaminated to the point where you get a pus exuding from these lesions. They look very clean when you see them. You agree with that, Daniel?
Yes, I do. And it's actually interesting if you think about it. Some people describe this as pizza pie, right? Like a pizza where they haven't overdone the cheese. Like I once ordered pizza with Dickson, extra cheese, never eaten that again. But if you put a reasonable amount of cheese, there's like a white, red sort of, and when you look at these lesions, and sometimes they could be fairly large, you see this red-white granular surface. They're not undermined. There is a redness and induration around the edge, but I've never seen a cellulitis.
Exactly.
So there's some sort of an interesting immune activation. And here is this open access to, you would think it would get super infected a percentage of the time, but I've seen, lots and lots of cases. I've never seen one super infected.
Has anyone looked for antimicrobial substances in the lesion itself?
Yeah, it's interesting. Are they doing something basically to say this is out of place?
Exactly,
No one else is welcome.
Exactly.
Yeah,
right.
they mentioned like antimicrobial peptides.
Like McGannon's.
Yes, exactly.
Sure.
As this paper goes, we're going to see that somehow the leishmaniasis infection is actually having an impact on bacteria in the area. And not only just in the area, but even over on that contralateral side.
I mean, there's a remarkable sequelae to this infection with Leishmania brasiliensis called espundia.
Espundia.
Yeah, it's in our book, and you can see this disgusting. I mean, I don't know. It's not a fair description. I don't think you should call any clinical sign or symptom disgusting, but it's a very difficult picture to look at because the entire soft palate of this poor little kid is eroded away. It's just all open. And yet,
the good thing is it healed, right?
And yet they can recover from this when they're treated, and plastic surgery can bring back all of the damaged tissues. They don't die from a microbial insult, which you would assume, my God, look at this big open lesion. Those bacteria must be pouring into that space, particularly in the oral cavity, which has its own microbiome, right?
Sure does.
That would be very interesting. Of course, they can't do that experiment because the animal model for this doesn't exist. So that's too bad. But it's a remarkable long-term sequelae to this infection. In some, like Daniel said, in 10% of the cases, you'd get these open wound lesions developing at the mucocutaneous junctions.
So the next experiment involves mice.
Right.
Infect them
with a different
Leishmania major.
That's right.
What's that? A mouse?
No, it's a human. It's a human. Well, it's got a multiple series of hosts, so it's kind of promiscuous in that sense. It'll infect canines and gerbils and gerds and all kinds of desert-dwelling, animals as well as people.
So they infect them in the ear.
Yeah.
And then they get a lesion,
yeah.
and then it resolves eventually. So they swab the ear before, during the lesion, and after.
Got it.
And they look for bacteria by the same ribosome.
The biodiversity of the bacteria.
Again, the diversity decreases.
That's interesting.
And then when the lesion heals, it comes back.
Okay, you know what?
And the staphylococcus goes up just like they saw in people.
They're onto something here, I think.
Okay.
Yep.
They also looked at the fecal microbiome. No changes. Okay. Good control.
Yep.
Leishmania is not affecting that.
Sure.
So somehow so it's nice and they have a mouse model now for this as well.
And the contralateral is good control too.
The contralateral is a good control, although in this initial experiment, they did not look at the
opposite ear.
But we'll get back to the opposite ear. It's coming.
Okay.
It's coming, Dickson.
Okay.
So now they have two mouse strains that have a different outcome. So C57 black resolve the ear infection, but Balb C, they get a non-healing ulcer.
Yes.
It stays for a long time.
They have an immune defect.
Now, both of these mice have lower bacterial diversity in these lesions, okay? But the Balb C mice, which have the severe lesions, have streptococci dominating, whereas the other ones have staphylococci dominating.
That is interesting.
Now, they deplete IL-12 in C57 blacks. Now, remember, C57 blacks, they heal the lesion. If you deplete IL-12, it now becomes ulcerating and non-healing, like the Balb C.
Exactly.
I don't know why they picked on IL-12.
Daniel, tell us.
There must have been some previous reason why they did that.
Well, that's the immune defect in Balb C, I think.
IL-12 may be one of them,
That's
right?
right. That's right.
And then depleting IL-12 makes it a non-healing lesion. That's pretty cool.
Yeah.
If you deplete IL-12, then you get staphylococci dominating in the skin microbiota. So they have a nice mouse model for looking at this. Now, Staphylococcus, where is the name of this damn thing? I lost it. Staphylococcus xylosis. Common commensal bacteria found in the mouse skin. That's what they find in these lesions as well. So they do an experiment where they put L. xylosis on the mice after Leishmania major infection, and they get a higher abundance of Staphylococcus species as well. So in other words, they wanted to know if the dysbiosis caused by Leishmania would influence skin inflammatory responses. So they put xylosis on, and that results in a higher abundance of staphylococci. They inject mice with S. xylosis, and that causes a higher production of inflammatory cytokines, IL-17, TNF-alpha, etc. So they think that this S. xylosis might be contributing to skin inflammation. So you get a barrier disruption by Leishmania. You have S. xylosis, Staphylococcus xylosis there, and that's going up, and that may contribute to skin inflammation. All right?
Yeah.
Next experiment, they use an irritant of the skin.
I thought when they injected it into the, that was an irritant, so to speak.
So this is a model of irritating the skin using a chemical,
Got it.
dinitrofluorobenzene. You know that?
Sounds pretty
DNFB?
Yeah, it sounds...
When you treat the mice of skin, so they colonize them with staph xylosis, and then they treat them with DNFB. You get an increase in neutrophils, IL-1 beta, increase in inflammatory responses. Okay?
It's like a DTH response.
And if you neutralize IL-17 or IL-1, you get fewer neutrophil recruitment. So the idea is that S-xylosis can induce these cytokines when you damage the skin, like by dinitrophenolbenzene, and presumably by leishmania infection as well. Right, that would be the idea.
Right.
They looked at streptococcus. It doesn't have the same effect as staphylococcus on this skin inflammation.
Mm-hmm. What happens to IL-12 with DNFB?
Didn't look.
They didn't look.
They didn't look.
Okay.
Yeah, I was actually, you dropped that question. I didn't really respond about the IL-12. I'm trying to figure out actually why they look at certain cytokines when they do and when they don't.
Yeah.
Sort of trying to use our immunology framework of Th1, Th2, and neutrophils, because now they're getting into neutrophils. But I think when they're looking at IL-12, what they're doing is they're saying, okay, leishmaniasis, intracellular pathogen, Th1 would be the dominant response. Think about what we know about leishmaniasis immunology, similar to tuberculosis, mycobacterium immunology. And we know that IL-12 is sort of critical in an enhanced and an effective Th1 response. And I would say, I think as Dickson sort of suggested, that BALB-Cs are not as good in a Th1 response. Right. And there is literature showing that when you augment with IL-12, you get a better Th1 response, whether it's against leishmaniasis or mycobacterial infection. Mm-hmm. But then they start getting into stuff where I think you're starting to look at neutrophil infiltration, cytokines, and particularly they're now going to start looking at IL-1 beta in neutrophil populations. So, the CD11B, Ly6G gating, they're going to start saying, okay, we're moving from a broad Th1 to a neutrophil response.
Right.
And, it is interesting because we also have timing on all this. This is like 6 weeks when we seem to reach a peak of the dysbiosis. So part of this is an acute inflammatory response, but then there's a little more of a chronicity here. So,
yeah. I might add that IL-12, I think, is important for immunity against toxoplasmosis. So it plays a wide role in terms of intracellular parasitism.
Yeah, yes, that is true.
So this is a cool experiment. Next, they infect one ear with leishmania, and that ear becomes dysbiotic. Then they look at the contralateral ear, and it too has a lower complexity of bacteria dominated by staph species. The other ear that's not infected.
So I actually thought this was really interesting, I will say. And the reason I say is because, right, we start off this discussion with Dickson sort of suggesting that maybe what's happening is leishmaniasis is sort of secreting an antimicrobial thing. We'll call it a secretory product.
Let's call it a thing. Thing one and thing two.
So they're
Doctor Who?
But what I think,
Dr. Seuss.
But what I think this paper is suggesting as far as mechanism is that what's happening is the leishmaniasis is somehow interacting with our immune system because you're getting an effect on the other side of the body. And I don't think the leishmaniasis is producing something that is then ending up on the other side of the body. They're creating an immune modulation that affects the skin microbiome.
Maybe. It could be.
I'm curious as to what the animal behavior would be if they had an ear infection, it was dermal, and they scratched, right? And then they scratched the other ear.
Well, yeah, maybe they're transferring the microbiome, the dysbiotic microbiome.
Right. Or are they individually housed?
You see, the gut microbiome.
So we're gonna get into this. Is this transmissible? Right. I don't know if we're quite there yet.
Yeah, that's the next question. So we know that gut microbiomes can be transmitted by co-housing mice. So if you have one mouse with a altered gut microbiome and put it with another one, it will transmit it. It's incredible. So they said, can skin microbiome also be transmitted? So they take mice with leishmania infection on the ear and they house them with normal uninfected mice. And they look at the skin microbiome, and it's screwed up in the uninfected mice.
Look at that.
Okay. Now, they just simply house them for 6 weeks, and the skin of the co-housed mice also acquire a high abundance of staphylococci, whereas the unco-housed are normal. So just co-housing them spreads this, as Daniel said, it transmits this dysbiotic microbiome. Okay. And these mice that have the microbiome transmitted, they're not sick. There's no inflammation. The ear doesn't change in any way. Somehow they're just getting the microbiome from the leishmania infected mice. So they say this gives us an ability to assess the consequences of dysbiosis on inflammation without having leishmania there, right? Because you can have this dysbiotic microbiome transferred. So they do an experiment. They co-house naive mice with infected mice to create altered dysbiotic mice without leishmania. Okay. And then they compare the contact sensitivity responses to this drug DNFB in the two groups. So we have leishmania infected, leishmania uninfected, but they both have dysbiotic microbiomes. The co-housed mice have more neutrophils and pro-IL-1 beta production than control mice, similar to mice that are infected with leishmania. So the microbiome alteration is leading to this altered inflammatory response. Isn't that cool?
It is.
So no leishmania, you just have the dysbiotic microbiome, and you can have this altered inflammatory response. So then they take these naive, then they infect these co-housed mice. Okay? So you've co-housed them with leishmania-infected mice. They've got an altered
microbiome.
And now you infect them with leishmania. They have more neutrophils and IL-1 beta compared to control mice that weren't co-housed with anyone. So having that bad microbiome there initially makes the leishmania infection worse. Increased skin ulceration, etc. So the skin microbiota influences the magnitude of lesion severity. So that's cool because you can look at that independently of leishmania doing it, right? Because you have that mouse, co-housed mouse that is got its altered microbiome. Now leishmania has a different pathological outcome. So it tells you that the altering of the microbiome probably contributes to the pathogenesis of leishmania. Make sense?
Yeah. Now I'm presuming, of course, since I just skimmed this paper.
Yeah, I got it.
That if you look at individually housed mice that had the microbiome alteration without the leishmania, if you leave them long enough, will they revert back to the normal type?
I would guess so, because when the lesion heals in the other mice, their microbiome reverts. Okay. So I would guess that that's true, but I don't think they did that.
This is transitory then.
Yeah. Because they pick it back up from the environment.
And do you think this has consequences for other microbial infections of the skin, like fungal infections, for instance?
Yes, so sure. There's always interactions among.
Yeah. I mean, are they more susceptible to other things because
that's a good
this?
question.
Or maybe less susceptible. I don't know.
I think that those are good questions that are definitely addressed.
Right.
And then they have some evidence that this is something going on in people as well, right? From that small clinical.
So this sounds like the prelude to another significance section to another NIH application.
So the question is, and maybe Daniel can address this, does this mean that you should use antibiotics to treat leishmania?
Oh. If there are any left.
Because here it's showing that the dysbiosis is participating in the inflammatory situation with leishmania, right? So should you co-treat whatever you treat leishmania with, should you also have antibiotics in there?
But in the C57 black mice, they will go on to heal.
They do.
The lesion resolves, and you don't have to treat them or anything. Whereas with the Baub C mice,
so people not heal. What did Daniel say? What fraction of people? 10%?
10.
Go on not to heal and develop
These are the
mucocutaneous?
Or they heal and then at a later date they have a mucocutaneous eruption, I should say.
So maybe they're dysbiotic for some other reason, and that's predisposing them to a more serious leishmania.
Yeah, exactly.
Right?
Yeah, actually, that is one of those unanswered clinical questions. Is right now, if you see someone and they have leishmaniasis brasiliensis, one of these mucocutaneous potential leishmaniasis, we uniformly treat them like we do PCR, so we can know, is this one that we need to worry about? But what would make much more sense is, can we identify what is it, who are those 10%, and treat those? Because 90% of people don't need to be treated. They're going to get better. They're going to be fine. And so maybe there's something here in looking at the skin microbiota and it telling us who is going to go on, who isn't. And maybe this would be even better. Maybe by modulating that, we can have an impact on who goes on to get mucocutaneous disease. I think these are fascinating questions.
Yeah, I totally agree.
So I wonder if the alteration of the microbiota as a consequence of Leishmania infection, is that beneficial to Leishmania, or is it an accident of something that they're producing? That's an interesting question.
This organism makes its living by eating cells. You will not find these organisms in the center of the lesion because that's where the dead tissue is. They're only at the marginal edge, all right? So if microbial infection of the lesion resulted in a wound healing response, followed from an abscess to a wound healing response, the organisms, Leishmania, would be probably sequestered into a fibrous scar or something like this without the living tissue to take advantage of. Whereas excluding microbes might leave all this living tissue for the Leishmania organism. That's just a guess, but you have to think of it
very
some
interesting
way.
So let me summarize this. So Leishmania alters the skin microbiota of people and mice. What you get a lot of staphylococci and streptococci. You can give this altered microbiome to another mouse that's co-housed with the infected mice. Amazing. And those mice that have the altered microbiome, they have a worse inflammation when you give them Leishmania. So this raises a lot of interesting questions, in particular the mechanisms, why this is happening, and how you could use this for treatment.
Sure. And how normal microbiome prevents inflammation.
That's right.
Because that's what it's doing, right? It's excluding the pathogens that would alter the way skin behaves under those conditions. Because that's our first line of defense. That's very important for us.
So this is going to be the case for most infections, that there's always an interaction with the microbiome in some way, positive or negative. This is not going to be unusual for sure. Did you know that the gut microbiome is needed for poliovirus replication?
And for trichinella success.
Is that right?
Yeah.
Gut microbiome.
Yeah.
Would you have imagined that when you first started working? No.
In germ-free animals? No, I got such a screwy result that I moved on to another problem. I didn't know what to expect. But it was
That's right.
variable.
Oh, yeah. You talked about that. Germ-free mice do not get trichinella.
No, some of them get huge infections and others don't get any. It was totally variable, and depending on what, they were all
So who's working on that now? If anyone.
It's expensive work, by the way, and it's very difficult because you work in an isolator the whole time.
So that's TWiP meets TWIM.
Yeah.
Daniel, you have any more case studies for us?
I do, actually. So this case study is, I will say, not as much of a medical mystery. I think people say, I know what this is. So what I want the questions
no
to
more
be
softballs?
Well, this is a softball one, but it will be a lot of a focus, hopefully a discussion. Hopefully this is timely when we come back and meet again. For what do we do? What are the sort of therapeutic approaches to this?
Okay.
So I'm going to bring everyone back to the little town in the Dominican Republic, Restauración. This is the fall of 2016, and I'm in this small town. And you guys actually, I've already mentioned our patient, and this is the little boy who is not behaving well, and his mother is warning him that if he doesn't calm down, that the worms. Remember this little boy?
I'm trying my best here.
I don't remember it. No, sorry.
So this was the.
But this came with his sister was sick, right? Is that right?
Yeah. So we were actually there specifically for the sister.
Yeah. Okay, I remember that.
But the mother's telling this little boy, if you don't sit still, if you can't stop being so irritable, los gusanos are going to eat you. Right?
The worms.
The worms are going to eat you.
Right.
And so after we address the issues that the little girl has, I the mom, who now has decided that she can talk to me, that I'm now friendly and nice, she asks me maybe if there's something that I could do to help her son. So she describes that lately, as we mentioned, the son is being more trouble. He seems irritable. He's not being as well behaved as he had been before. And she's now noticed these things in his hair. Right. So she brings him over and we start looking through the hair, and he's got these small, we're going to say like somewhere between a poppy seed and a sesame seed things on the hair shafts. And they're on the side of the hair shaft. Right. They're a little bit up. I think Dickson knows what this might be. And what's she doing? She's picking them off with her fingers and sort of smashing them between her fingers. And she's trying to go through the boy's hair and do this. So she wonders, what are these things, and what do I do about it? And we'll give people context. Right. This is a very, very simple dwelling, dirt floor. There are walls and a tin roof. Animals, etc. And then this little boy who's become more irritable, and he has these things in his hair. And so she doesn't have any money to buy any medicine. So she wants to know, what can she do to treat her son? What is this? Okay.
Okay. That's what we need to.
It's okay.
It's okay.
Yeah.
It's okay. What's okay?
And I think we mentioned
know anything more.
Okay. And I think, as we mentioned, he's only 2 or 3 years old, so he's a young boy.
Yeah.
Dark hair. Yeah. Hair is medium length.
Exactly.
All right. Dickson feels like he doesn't need to know anymore.
Know that these things could alter your behavior. Yeah.
Big time.
I didn't know that. Now, should I ask about what he eats? No.
You can.
I think
by being breastfed.
Okay.
Actually, that was part of the visits we did, is we tried to educate these young mothers about, nutrition. So breastfeeding's often done till 2 or 3 years of age, right? So the boy's sort of at the tail end of that. And we were trying to encourage them to, when they could afford it, vegetables, right? Because a lot of sort of carbohydrate diet.
So does he sleep on the dirt floor?
They do have these raised sort of bed platform areas where the kids sleep, where they're actually off of the floor. But,
okay.
He's spending most of his day sitting, crawling around barefoot on these dirt floors.
And he's got a sister that he probably plays with or interacts with, right?
Mm-hmm.
And no other siblings, right? Doesn't go to school, obviously. He's too young.
No,
doesn't go to school.
No daycare centers.
There's no daycare center.
Okay. You okay, Dickson? You got it?
I think so.
Solved?
I think so.
The real key here is what to do when she can't spend a lot of money.
That is correct. And there is something that she can do that doesn't cost very much money.
Okay. Well, let's see if our listeners know that.
All right.
Right, Daniel?
Okay.
All right.
Yeah.
Got it.
All right. It's 6:05. Let's read just a couple of emails. Okay. Got time for that, Daniel? Just a few?
I do.
All right.
Excellent.
Now, the first one is from Michael Martin, MD, who writes, Dear Gamesters of TWiPskelion. All right. Now, that is a reference that Dickson will not get.
You're right.
Daniel, do you get it?
TWiPskelion.
No, you don't. It is the title of a Star Trek episode, The Gamesters of Triskelion.
Oh, okay.
Gamesters of Triskelion. I'll go back and look.
Vincent, Daniel, and Dickson in absentia.
Yeah.
I listened with both amusement and interest to the last TWiPcast concerning pinworms, and I thought I would send in a general pediatrician's perspective. I remember hearing from an older colleague when I was an intern, rectal itch, Vermox, mebendazole. Vaginal itch, Vermox. Shouldn't I do a paddle test first, I asked. Waste of time. The test costs $15 and the Vermox is $25. I was confronted with reality this past winter when I had a family who all had pinworms. They tried several rounds of parental pamoate without success. I tried to prescribe Vermox, which was denied by the insurance company because the pills were now $500 each. And anyway, not available currently in the U.S. They suggested albendazole, which cost measly $200 a dose. I have since learned that a new mebendazole M-Verm will be available, but I have no idea of its price point. I must admit, I sometimes make a leap to the diagnosis as I did in this case, so I was glad that one reader sent in a proper differential diagnosis of rectal itching. I have spent a professional lifetime trying to make sure I at least consider other diagnoses so as to avoid premature closure, a dangerous cognitive bias. The case this week also made me jump to a conclusion. As I was listening to the podcast, I concluded that the child had ascariasis. I wasn't sure whether the place, Dominican Republic, was relevant, but that poverty and the lack of modern facilities for the disposal of waste were. One further anecdote, when I was first in practice, a mother rushed into the office hysterical at having discovered a large worm in her toddler's diaper. I figured it was probably ascaris, but as she had the worm in a bottle, we sent it to the lab for more expert identification. The report was not Ascaris lumbricoides, as we expected, but Lumbricus terrestris, the common earthworm. The solution to the case was the 4-year-old sibling who thought it would be funny to put a worm in his brother's diaper. I wager 100 quatlus that I will continue to listen to TWiP. Now, quatlu is probably also a Star Trek currency.
It was apparently the currency used in that episode.
The Gamesters of Triskelion. Yes. That's very interesting. Does this ring a bell, Daniel?
No, it does now. I didn't quite get it, but now I am actually quite a Trek fan. You know, there's 3 levels of Trek fans. I don't know if you're familiar with the levels.
Really? Tell us.
So level 1 is people who enjoy Star Trek. Level 2 are people who within 15 seconds can name the episode. And level 3 are people living in their parents' basement who believe they're actually on the bridge of the Enterprise.
Yes. And they're probably smoking something very exotic.
So, I am not a level 3 on this.
No, I'm certainly not a level 2, but I watch it every time I stumble on, no matter which level, in this case, the early shows, the middle, and then the later on Star Treks starring other people.
Do you take the next one?
Tanner writes, TWiP 135 case study. Hello, esteemed members of TWiP. I am writing from Flagstaff, Arizona, where the monsoons are bringing relief to a hot and wildfire-prone time in the Southwest. Thank you for your continued work bringing the world of parasitism to life for interested listeners. I am a huge fan. I have a BS in geology and work as a fisheries biologist in Grand Canyon National Park. Oh my God, you are so lucky. Pursuing becoming an expert in Grand Canyon ecology. Over the last couple of years, coincidentally, when I began listening to TWiP, I began documenting the presence of parasitizing larval trombiculid mites on various lizard species found on the Colorado Plateau. See attached photo. I plan to turn this special interest into a master's project in the coming years. Sounds like a great idea. Case study. The gentleman living in Queens, suffering from an itching and burning foot blister, sounds to be suffering from a classic case of guinea worm. Now, this is from an older case.
Yeah, you could skip most of it.
Oh, okay, then.
You could skip that paragraph.
And the next one?
Yeah, I think you could skip it all.
It's a great picture of the lizard.
So go down to the PS.
I go to the PS. PS, the photograph is the one I took of a Great Basin collared lizard, Crotaphytus bicinctores, taken near the Little Colorado River in October of 2015. The individual had heavy mite loads on its haunches, forelimbs, and ear openings. It was also behaving uncharacteristically sluggish in the heat of the day.
Are those red things, the mites?
Those are the mites.
Wow.
They are the mites.
So is that bad for the lizard?
Of course. Mites suck blood. That's why they're red.
How does it get rid of it? Can you see a doctor?
No. It can get rid of it by being eaten by a snake.
And the snake will get the mites?
The snake, no. They'll just be ingested and they'll digest them all.
Oh, poor lizard.
North American man. That's Anthony.
That's a tough life, nature, isn't it?
Tell me about it.
You can read the next one.
Okay. Anthony writes, North American mammals are afflicted by a species of guinea worm.
Oh.
Interesting. I wonder if the cyclops or perhaps Daphnia water fleas that live in ponds and lakes here, New York, in the metro area, and in other parts of the U.S. can serve as a link in the old world guinea worm's life cycle. I wonder if the juvenile guinea worm can survive the winter in a copepod as a hibernia. I doubt it. Presumably the water that was used to soak the afflicted's foot was just dumped down the drain. I wonder if any larvae released were consumed by copepods in the sewer. That's a good thing to wonder about. Right. Hard to know, but I think copepods demand clean water, so I think they wouldn't be found in sewage.
All right, let's do two more. Daniel, can you do Harlan's and Hitoshi's?
Harlan writes, Dear TWiP, I am a fan of the listeners getting to participate in the differential diagnosis, a bit less of the newfangled audio files compared to the letters helpfully interspersed with commentary from the host and perhaps occasionally truncated. It's a bit long-winded. Glad that Dickson is back. Harlan, Kanoa, and Shepherd, Honolulu. All right. Hitoshi writes, Dear TWiPtoids, I am a vector entomologist working on Aedes mosquitoes, longtime listener, first-time emailer. I subscribe to TWiV, TWiM, and TWiP. I like TWiP the best.
Hey.
I meant to email much earlier, but could not, and now I do because it seems that the question is still a mystery. It sounded solved in the show. Sorry, I am not giving answer either. on TWiP 131, a question was brought up about tick-bearing young.
Yeah.
I thought that Jonathan Larson answers it, or at least gives some thoughts on it, and in TWiP 133, Anthony wrote on Google search on tick viviparous, which resulted in some sheep ticks. As you may already know, sheep ticks or sheep keds generally does not refer to true ticks.
That's right.
But instead they are insects.
That's correct.
Sheep keds belong to the family Hippoboscidae in the order Diptera.
Bingo.
So they are actually flies.
See that?
Adults of Hippoboscidae are dorso-ventrally flattened, brown-colored, and some are wingless aptopterous, which resemble ticks. And although they look different, Hippoboscidae are close relatives of Glossinidae, tsetse flies, and they bear fully developed larvae.
Look at that.
The larvae does not look like adults because flies undergo complete metamorphosis and transform into a pupa and then an adult. If Dave had seen a tick bearing a young, it would have been a sheepked. Yeah. But he described that out of the cut in the half tick came a pile of baby ticks. The one Dave has seen was not Hippoboscidae because a fly can bear only one larva at a time. I guess the tick eggs may develop in the mother and burst out after hatching. Sorry again, this is not the answer. Keep up the good work.
Oh, I thought we had it there.
We did. Yeah, well, all right.
So the Hippoboscidae only have one, so it couldn't have been that.
That's why they're related to Glossini, because the tsetse flies only lay one at a time also.
Yeah, I remember being asked this question once about the tsetse flies is how many eggs does a tsetse fly lie?
So basically, you're saying that tick eggs may develop in the mother and burst out after hatching. Is that right?
I guess we'll have to accept that.
All right.
We should have asked Marshall Bloom when we were out in the meeting.
Oh, that's a good question. A good idea. I will send him.
He would know the answers to that.
Is he a tick expert?
Sure.
I know he works on them.
Tick-borne encephalitis. I'm sure that he knows about the vector. Sure he does.
Okay. Yeah. Then let's wrap up TWiP 137. You can find it at app. We have lots more emails, but we'll get to them another time. You can find it at Apple Podcasts, microbe.tv/TWiP. If you like what we do, consider supporting us financially. You can go over to microbe.tv/contribute. We have some newfangled ways you can help us. There's a Patreon account where you go to a website and you can subscribe for $1 a month. And you can cancel anytime, so it's no risk. And that would help us a lot. And that does things like getting Dickson to come out to Montana with me.
Which I did.
Which he did. And we did a TWiV, and he showed me what fishing was all about. So that's microbe.tv/contribute. And of course, send your questions and comments and case guesses to TWiP at microbe.tv. Daniel Griffin is at Columbia University Medical Center, Parasites Without Borders, and parasiticdisease6.com. Thank you, Daniel.
Pleasure as always.
Dickson Despommier is at Trichinella.org and thelivingriver.org. Thank you, Dickson.
I'm glad to be back.
Now I understand the fascination with the living river.
Okay.
Very interesting. I'm Vincent Racaniello. You can find me at virology.ws. The music you hear on TWiP is composed and performed by Ronald Jenkins. You can find his work at ronaldjenkins.com. I want to thank the sponsor of this episode, Blue Apron. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
is parasitic.